Hey everyone, welcome to Chapter 9. Um, so Chapter 9, 10, and 11 are all about industry structure. What that means is we're going to be looking at different industry structures and trying to figure out how producers are going to behave in order to maximize profits. So in these industry structures, Chapter 9, we have price takers and price searchers. So this would be similar to pure competition or um, monopolistic competition, which is another way to say price searchers. But from here on out, every single multiple choice question will define whether it is a price takers, price searchers, oligopoly, monopoly market structure. So every single multiple choice question will tell you what market structure to focus on in order to answer the question. Likewise, they will also emphasize short run versus long run because there's different answers in the short run versus the long run often. So let's take a look at price takers and price searchers and see the difference in market structure and what that means for producer behavior. All right, so price takers versus price searchers. Price takers, they are going to produce an absolutely identical product. And this is probably the most important characteristic for a price taker. Each of the firms are small relative to the entire world market, and they're going to sell all of their output at the going market price. So for instance, let's just say you're a cattle farmer and you're going to sell beef. Well, the price per pound of beef is going to be the same for you as everybody else in the United States. Likewise, wheat farmers, they have an identical product of wheat. It could be winter wheat or summer wheat, but it's still an identical product and everybody gets the same price per bushel. It's set in the world market. And so this is the element of a price taker. It is a firm that has to take the going market price in the world. It could be fishermen, loggers, they all sell pretty much the same product as everyone else, and they're small relative to the entire market. So that's a price taker. It takes the price from the world. It doesn't get to set the price. Now, price searchers, there's still a lot of competition in this type of industry. However, they do get to choose their price. Say, for instance, if you have a pizza restaurant, there's tons and tons of competition. You are small relative to all restaurants around. However, basically what we've got going on is that they get to choose their price. Is it going to be a high price pizza? Is it going to be a low priced pizza? They're going to be searching for the absolute best price to maximize profit. They're going to be choosing whether it's a high grade pizza like Brucci's or Mellow Mushroom or a low grade pizza like Papa John's. So you're going to be searching within this spectrum. You do not have to charge the same price for your pizza as everybody else. You are a price searcher, not a price taker yet. In both of these markets, there's lots and lots of competition, lots of rivals. So let's keep taking a look. Let's look at first price takers. The characteristics of price takers, which you have to know, is that they have homogeneous or identical products. So one semiconductor is exactly like the next semiconductor. One bushel of wheat is exactly like the next bushel of wheat. They have identical or homogeneous products. There's many buyers and many sellers, so that any single seller is small in comparison to the huge market. Likewise, there's no barriers to entry, so anybody can become a farmer. Anybody can become a logger or a fisherman. And full information, everybody knows the product characteristics and the product price. The real thing that changes here between price takers and price searchers is homogeneous and identical products, many buyers, many sellers, and no barriers to entry. Full information we pretty much assume throughout until you get to more advanced economics, and then we drop that assumption and look more into that. So in a competitive price taker market, firms can sell all of their output at the market price, produce differentiated products, can influence the market price by altering their output level, or are large relative to the total market. Notice all these clicker questions, they tell you what industry to focus on. Here we're focusing on competitive price takers. Every single multiple choice question will now define that. All right, here, they can sell all of their output at the market price for the most part. So basically what we've got going on here is we see that in the market as a whole, we have a demand for wheat and a supply of wheat. And this is throughout the entire world. A demand for wheat and a supply of wheat. These are thousands and thousands of buyers and thousands of sellers. Lots of buyers and sellers. So in this market with demand and supply, they have a going world market price, and that is the price that the firm has to take. So what's the price if they sell 10 units? If they sell 10 units, the price is P. How about if they sell 100 units? If they sell 100 units, they're going to be out here, the price is P. Does everybody see how the price line is also the firm's demand curve? It shows the prices and quantities that producers or consumers will buy and sell. The prices and quantities that consumers will buy and sell. It's a straight line demand curve, perfectly elastic for the competitive price taker. So how does a price taker maximize profit? Basically, we're going to set marginal revenue equal to marginal cost. So we need to define what is marginal revenue and what is marginal cost. And then I will show you that when the producer chooses an output level whereby marginal revenue, the additional revenue that you can get from selling an extra unit, is equal to marginal cost, the additional cost that you incur from producing that unit. Well, when marginal revenue, the additional revenue, is equal to the additional cost, that will be the level that will maximize output. I promise that'll always work. And that is a decision that will be true chapters 9 and 10 and 11 for the most part. So here we have marginal revenue. The marginal revenue is going to be defined as the additional revenue that I get when I sell one more unit of output. If I'm the producer of pizzas, how much additional revenue do I get from selling one more unit of pizza? The additional revenue. Well, so for the wheat producer, what's the additional revenue? To sell one more bushel, what's the addition? Oh, it's the world market price. Do you remember that when they sell one extra bushel of wheat, the marginal revenue for the price taker is also the price, the world market price. How much more money does he get for selling one more unit? The additional revenue, it's the price. In chapter 9, marginal revenue is equal to price. In chapter 9, marginal revenue is equal to market price. This is the only chapter where that occurs. But all of these rules will work throughout all the chapters. But in chapter 9, when it's perfectly competitive market throughout the world, marginal revenue is equal to price. So basically, what we're going to learn is how does the producer behave? The producer will behave as in where marginal revenue is equal to marginal cost. That will get you Q star. That'll be the optimal output for maximizing profit. What we'll learn is that if marginal revenue is greater than marginal cost, increase output. If marginal revenue is less than marginal cost, decrease output. Output in the short run, the optimal profit maximizing output is found where market price is equal to marginal cost, because that's marginal revenue equal marginal cost, is where market price is equal to marginal cost. Let me show this to you. All right, so we need to be able to do this both numerically and graphically. You have to know it both numerically and graphically. So let's get into the numbers here. All right, so we got a price of $5. $5 per unit. What's total revenue when output is 0? Total revenue is also 0, isn't it? How about when output is 2 and the price is 5? Marginal revenue, total revenue is 10. How about when it's 8 units? When it's 8 units, it'll be $40. When it's 10 units, it's going to be $50. When it's 12 units, blah, blah, blah. We get the idea. All right. Does everybody see how total revenue is equal to price times quantity? Everybody sees how we got these numbers? Good. Marginal revenue. It's the change, which is delta. Delta is meaning the change in total revenue over the change in output. As we go from 0 to 2, we have the additional revenue will go from 0 to 10. So it'll be the additional revenue will be 10 and the additional output will be 2 because we're going from 0 to 10 and 0 to 2. The change in total revenue is 10. The change in output is 2. And so that's going to be 5. How about here? The change in total revenue is going to be 30 because we're going to go from 10 to 40. And then the change in output will be 6. So the change in output will be 6. 30 divided by 6 will be equal to 5. Oh, my word. Marginal revenue in Chapter 5 is equal to market price. Marginal revenue in Chapter 9 is equal to market price. Does everybody see how we got that? All right. We also have marginal cost. Marginal cost is the change in total cost divided by the change in output. So the change in total cost, it goes from 25 to 33.75. So that looks like $8.75 is how much cost increased. Total cost went from 25 to 33.75. The change in output is 2. So there's your marginal cost, the additional cost. Here we're going from 2 to 8 units. So the additional cost, I have to really calculate this, is 8 and 6 is 14. Is that right? The difference between 48 and 33.75. I think that's right. Divided by 6. That would be your marginal cost. Make sense? Let's take a look and see how all of these numbers worked out. All right. So my marginal cost is $4.37. At 2 units of output, we have marginal revenue of 5 and a marginal cost of 4. We got $4.37 because that's $8.75 divided by 2. $4.37. Does everybody see where we got these numbers? You got to be able to calculate these. Given your output and your total cost and then your price, you've got to be able to calculate all of these numbers. This is what you need to do numerically for sure. You've got output, total revenue, total cost. Marginal revenue is always 5. My marginal cost I'm going to be calculating as a change in total cost divided by change in quantity. Good. And then profit is going to be total revenue minus total cost. Profit is going to be equal to total revenue minus total cost. So here, profit is negative $23. Make sense? All right, good. All right, so let's use the rule for Q star. How do we get Q star? Q star is where marginal revenue is greater than or equal to marginal cost. Marginal revenue is greater than or equal to marginal cost in all of these output levels. Here, look, marginal revenue is less than marginal cost. Marginal revenue is less than marginal cost. You've gone too far. You got to back up. This is Q star. Does everybody see how Q star is where marginal revenue is equal to marginal cost or as close as possible? Marginal revenue is as close to marginal cost but not greater. All right, so this is going to be Q star. Q star is 15. Q star is 15. What's profit? Oh yeah. Oh yeah. Look, it's maximum profit. I told you it was maximum profit. I told you that if marginal revenue equals marginal cost, they're going to maximize their profit. And indeed, look, they did. Maximum profit. So now you can trust me. Everybody understands the rule? Everybody knows how to calculate these things? And then you know the rule, you know Q star. We can find it numerically. Now let's do it graphically. So we've got my average total cost and my marginal cost, right? Average total cost and marginal cost. Where does marginal revenue, where's Q star? How do we find Q star graphically? Well, look, in chapter 9, the price taker market, this is your demand curve and price is equal to marginal revenue. There's your marginal revenue curve. It's the price line. Remember, it's 5 all the way across. Your marginal revenue is always 5, at least in that numerical example. Here, this is your marginal revenue line, marginal revenue. All right, where's Q star? Where does marginal revenue equals marginal cost? Ah, look, it's at B. At marginal revenue, it equals to marginal cost. Do you guys see that? There's your Q star. I would like to put a star on here because it should be a star. It's a Q star. So that is going to be your maximum profit. They're going to choose output at Q. Notice, if marginal revenue is less than marginal cost, you reduce output. If marginal revenue is greater than marginal cost, you increase output until you're at Q star. Does everybody see that? All right. So we've got the price per unit, right? We've got price per unit. At Q star, what's the cost per unit? At Q star, what's the cost per unit? You go straight down. First you have to find Q star and then you go straight down. And that is where you have your cost per unit. You get it off the average total cost curve at Q star. You have to find Q star. Sorry, I don't want to get in your face. But you have to find Q star. All right, whether it's a numerical or whether it's a graphical, you guys, you got to find Q star. Once you find Q star, then you can find your price per unit, your cost per unit, and then profits. So this is your Q star. Everybody sees marginal revenue. This is your marginal revenue curve, you guys. Marginal revenue is equal to marginal cost. That's how we found Q star. There's my Q star. There's your price per unit, cost per unit, and this entire area is your profit. You're going to have to be able to calculate that numerically as well. Given P, given C on a graph, make sure that you can calculate the area of this rectangle. They're definitely going to ask you for that. So we can see it numerically, we can see it graphically. So make sure you can calculate the table in the previous slide if you're given product price and total costs. Notice, what's my fixed costs? Fixed costs are 25. Because when output is 0, we still have to have costs. There's my fixed costs. FYI, we'll be using that later. So another way to do this is to look at maximum profit by calculating total revenue and total cost. So we can find Q star either by looking at marginal revenue or marginal cost or by calculating profit. And you'll see that there's lots and lots of problems, multiple choice problems, where you get the choice of either calculating your profit. Q star is either maximum profit or where marginal revenue equals marginal cost. In this case, the problem gave you total revenue, total cost. So we can see profit here. And profit is maximized at 11. So you know, based upon this graph, that Q star is 15 because that's where maximum profit is. So do you see that we don't even need to calculate marginal revenue equals marginal cost? We can also do it here as maximum profit. We can find Q star with this maximum profit. I'm sure my computer will catch up anytime now. Yeah, it did good. All right, so marginal revenue. This is my price line. Marginal revenue is equal to marginal cost, and it's right here at 15. So we can find it either this way, maximum profit calculate profit and get the maximum one and find 15. Or we can calculate it in terms of marginal revenue and marginal cost and get it that way as Q star 15. It's all, the whole point is to find Q star, maximum profit. All right, so try and do this one. Table provides information on a competitive price taker firm. They've identified what chapter I need. All right, table provides information on competitive price taker firms' output, marginal revenue, and marginal cost. If the firm is currently producing 14 units, what would you advise them to do? They're currently producing 14 units. So at 14 units, their marginal revenue is 9 and marginal cost is 7. They should produce 16, shouldn't they? They should increase their quantity. If your marginal revenue is greater than marginal cost, increase output. If marginal cost is greater than marginal revenue, decrease. Profits are maximized when you choose, I would like to put a Q star on there. That's going to be your Q star. For perfect competition, your Q star, that's chapter 9, is where marginal revenue is equal to price is equal to marginal cost. Good? All right, so these are the rules. These are rules of how firms are going to behave when prices change in the market. And these are the rules, but you have to apply them at Q star. These rules do not work unless it's at Q star. Don't try and apply it anywhere else except Q star. All right, so the first rule is if the price is in between average total cost and average variable, so you're covering all of your variable and part of your fixed, you're going to continue to operate in the short run. If price is less than average cost per unit, remember average variable cost, that would be variable cost per unit. If you're not even covering your variable cost per unit, get out of business. You should not be in this market. You can't cover your fixed costs or all of your variable. You're not covering any of your fixed and you're not even covering your variable. Here at least, you're covering all of your variable, price is greater than average variable, so you're covering all of your variable costs and part of your fixed. Here, you're not even covering any of your fixed and all of your variable. You're not covering your variable costs. You got to go out of business. In the long run, you really want your price to be greater than your average total cost so that you can sustain zero or positive profits in the long run, ideally. All right, so let's apply these rules. Where is price relative to average variable and average total? First, we find Q star. Notice, at this one, my price is $5. I'm going to change prices here over the next few graphical representations, but in this case, things look pretty good. Price is $5. We have an output. We have output here. Price, so we get total revenue. There's my total cost, so here's my marginal revenue. And now we've also put in average total, average fixed, and average variable in there. We put those in as additional information. And marginal cost and profit. So there's a couple of different ways to find Q star. We could find it by marginal revenue greater than or equal to marginal cost, or where profit is maximized. So we can just look at, we can calculate profit and find, hey, where is that the largest? Okay, it's right here. Well, is that consistent with marginal revenue greater than or equal to marginal cost? Yes. Marginal revenue greater than or equal to marginal cost. Uh-oh, here we've gone too far. Marginal cost is greater than marginal revenue. We shouldn't produce 16. We should go back up. All right, so does everybody see that this is Q star? Good. At Q star, price is 5, and where is that relative to average total, average fixed, and average variable? Okay, in this case, marginal revenue is greater than that. My price is greater than that. So What rule does this correspond to? My price is greater than average total cost. Does everybody see how 5 was greater than your average total cost? And it was greater than average variable and average fixed too, but it's also greater than average total. So, sorry, in this one, the price is greater. The price isn't less. I was thinking price is less. No, price is greater. Yay, I found the right one. I'm sorry, you guys. All right, so price is greater. No, continue to operate. No, that's wrong. We want this one. Price is greater than average total cost. In that case, then you should stay in business. Price is greater than average total cost, you stay in business, which is what our first one was. Price, greater than average total, greater than average fixed, and greater than average variable. Making positive profits, stay in business. All right, let's go down to this one. Ruh-roh. Price declined to $3.25. Price declined to $3.25 in this market. Price of wheat is really low. So we recalculate total revenue. My total costs are the same. We have marginal revenue of $3.25 because in Chapter 9, price is equal to marginal revenue. So marginal revenue greater than or equal to marginal cost. So let's compare this to this. Right? We're going to compare marginal revenue relative to marginal cost. Marginal revenue is greater, marginal revenue is greater, greater. Uh-oh, it's less here. Marginal revenue is less. So we shouldn't produce 15 units. We shouldn't produce this one because I got a marginal cost of $4.75, a marginal revenue of $3.25. Marginal cost is greater. So our maximum profit is indeed negative 13. All right, so where does marginal revenue or price relative to average total, average fixed, average variable? Well, it looks like my marginal revenue, it's less than average total, but it's greater than average variable. Does everybody see how my price, it's going to be less than average total, but greater than average variable? So what kind of rule is that? My price is greater than average variable, but less than average total. So what this says is that we should continue to operate in the short run. Well, let's go look at that. That doesn't seems like a bad idea to me. You're losing $13. Why are you going to have me operate in the short run if I'm losing $13? What if I shut down? How much do I owe? If I produce 0, how much do I owe? I owe 25. If I shut down, I owe 25. If I continue to produce, how much do I owe? I only owe $13.75. Should I continue to produce even though I'm losing 13? Yes, you should in the short run. You should definitely continue to produce in the short run. Even if you're losing $13, you would be losing $25 if you shut down. Does everybody understand why, at least in the short run, you're going to continue to produce? And this is where you're covering all of your average variable. You're covering all of this cost per unit and some of your fixed. That way you're only losing 13. So you should continue to produce in the short run. Yay, it worked. All right, because you're going to minimize your losses for the most part. All right, now my price goes down to $2. Oh my gosh, it really fell. So I got my total cost, my marginal revenue, and my Q star in this case is where marginal revenue is greater than marginal cost, and I didn't go too far, at 12 units. So at 12 units, should they continue to produce? Well, here, my price is less than average variable cost. Look, my price is less than the average variable cost. I'm not even covering my variable costs. I should go out of business. And that's kind of true, because if I continue to produce, I'm losing $29. If I go out of business, how much do I lose? I lose $25. So it's a much better deal to just go out of business. If your price is less than average variable cost, go out of business. You'd be better off. All right, so let's take a look at some of these questions. Wheeler Farm sells wheat to a grain broker in Seattle, Washington. Since the market for wheat is generally considered to be competitive, they just told you what chapter to focus on. The Wheeler Wheat Farm maximizes profit by choosing which one looks right? Yes. You would think now, before you took this class, you would have said, well, you're going to minimize average variable cost. You're going to produce where average fixed cost is minimized, where it's even no. After this class, what you know is that the quantity at which the farm's marginal cost is equal to the market price. Marginal revenue equals marginal cost. That's your Q star, and they will maximize profit. That's how firms will behave. How about this one? All right, so they sell their clappers for 40. Present rate of output, marginal cost is 40. So should they increase or decrease output? Marginal revenue equals marginal cost. Should they increase or decrease output? No. Marginal revenue equals marginal cost, so they should not change their output level. Now, price is 40, average variable cost is 45. Average total cost is 60. So the price per unit is less than the variable cost per unit. The price per unit is less than variable cost per unit. They're not even covering their variable costs. They should shut down. Make sense, you guys? They should shut down. And so this is kind of putting into words what we did numerically and what we did graphically. So it's kind of putting it into words. And so you got to get used to transforming words into graphs so that you know that if they sell clappers for 40, then that's the price, and that's also the marginal revenue in Chapter 9. The marginal cost, and then the cost per unit, variable cost per unit, and total cost per unit. How about this one? It'd be D, same as the firm's demand curve. How about this one? Ooh, where's Q star? Right. So let's find Q star here. It is marginal revenue is equal to marginal cost. Here's my marginal revenue. It's the price line is equal to marginal cost here. So there, does everybody see that that's my Q star? There's my Q star. So there's at that Q star, the price per unit. Here's your variable cost per unit. And here is your average total cost per unit. Straight up there where it cuts here. There's your average total cost per unit, your price per unit, average variable cost per unit. So at Q star, should they go out of business? No, they shouldn't go out of business. They should definitely stay in business because the price per unit is between total cost per unit and variable cost per unit. Price per unit is between total cost and variable cost. Does everybody see how I'm always looking at Q star? So in this case, we know that they are taking economic losses, but they should stay in business in the short run. Make sense? They're taking economic losses, but they should stay in business in the short run. All right, let's do this. How about that? Should they stay in business? I'm going to get rid of this Q star because that's no longer applicable. Yes, there would be Q star would be right here, right? Where your price line is equal to marginal cost. Price per unit is greater than cost per unit, and there's your profit. How about if we move it down here? Where's Q star? Really hard to figure that out. It'd be right here, would be your Q star, but at this Q star, the price per unit is less than variable cost per unit, isn't it? At this one, you're not going to go down, you're not going to choose this, you're going to choose this one. And here, variable cost per unit, total cost per unit, it's less. Your price line is less. So you would go out of business. Hope that was helpful a little bit. So we have to do this numerically, graphically, and then also in words. So basically, a firm is going to maximize its profits along the marginal cost curve. So notice that the firm is going to choose to produce, get this to, so basically it's going to choose to produce as long as, I'm going to get this, you guys. I think I can do this. So as long as it's above this average total cost curve, basically anything above here, average total cost, my marginal cost is above my average total cost here, that's going to be the firm's supply curve. Because they're going to choose to supply anytime the price is above average total cost in the long run. In the short run, they're going to choose to produce along the marginal cost curve above average variable cost. This will be the firm's supply curve. It'll kind of start here. Because below average variable cost of P1, they're not going to produce. They're not going to choose to produce. They're going to shut down, even in the short run. So in the short run, it's going to be the marginal cost above average variable cost. And so that's just exactly what we're talking about. The firms are price takers. The short run market supply is a horizontal summation of the marginal cost curves above the average variable cost curves for all firms in the market. So basically, we're going to add this firm's marginal cost above average variable, that firm's, and so it's going to be the horizontal summation. We're going to add it up across. We can also see this. This is kind of an interesting problem. So let's look at this problem. So this is an industry whereby they can open in the winter or they can open in the summer. Their revenues in the winter are a lot better. They get monthly revenues of $10,000, variable cost of $6,000, fixed cost of $1,000 per month, and then a net revenue of $3,000. So should they produce in the winter? Yeah, they should. They should produce in the winter because they're making money. They're making $3,000 a month, which is pretty good. In the summer, they make less revenue, but they're definitely covering their variable costs, aren't they? Their revenue is $5,000. They're covering all of their variable. They're covering part of their fixed, so that their net revenues are negative $600. Should they continue to produce in the summer? Well, what if they shut down? If they shut down, they owe $1,000. If they continue to produce, they only owe $600. Should they produce? Yes. they should produce. So they should operate in both the winter and the summer. Basically, your revenues have to cover your variable costs, all of them, in order to stay open in the short run. Your revenues have to cover all of your variable costs, and then hopefully some of your fixed too. Kind of tricky, huh? All right, so in the short run, we have the short run supply curve. It's the area above the average total cost or average variable cost. Actually, in the short run, it's above the average variable. In the long run, it's above the average total cost, the marginal cost curve. This is how firms are going to behave. They're going to behave this way and set price equal to marginal cost in order to maximize their profits. All right, so let's talk about the long run. In the long run, if firms are earning economic profits, this is the long run story. In the short run, we know their story. They're going to continue to produce as long as they're covering all of their variable costs plus some of their fixed. Hopefully, they're making some profits too. But this is a super competitive industry. So we've got to think in the long run, what is likely to happen to these highly competitive firms in a highly competitive rival industry, lots of rivals. So if you are, say, a pizza place and you just opened your doors and you are bringing down the bucks, you're making maybe $1 million a year, what do you think is going to happen? Free entry, free exit, anybody can enter the industry, any rivals can enter. Well, what you're going to get is you're going to get a ton of competition that is going to copy your product and the way you do business, etc. I'm thinking of maybe Yoga Berry, right? We had no such thing as frozen yogurt 10 years ago. Now we introduced Yoga Berry at $12 a quart or something ridiculous. People loved it. They were bringing down so much money. And now what do we have? We have tons of rivals. We've got fat-free yogurt here, Moshi there. We've got all sorts of stuff. So basically, anytime you're making a positive economic profit, in the long run, you're going to have lots of rivals entering in order to capture those profits. So this is kind of the story. If your price is above average total cost and you're bringing down the profits, then this will induce entry of new firms. New firms are going to enter. More people are going to open up frozen yogurt shops, and expansion in the scale of operation of existing firms. I'm going to go ahead and open another store. I'm going to expand the store that I have for the most part if I'm bringing down the bucks. So capital moves into the industry. As more people enter the industry and build frozen yogurt stores, what we suggest is that in the long run, the new rivals and fierce competition will probably drive those profits to zero. So zero economic profits, remember, it's not bad. Zero economic profits are not a problem. Zero economic profits, you're paying yourself, your business, your resources as much as they could earn elsewhere. You're just not bringing down multi-millions on it. All right, so let's kind of see what goes on. So this is kind of your long run equilibrium. We're going to start at P0. So let's say there's positive economic profit at P0. At P0, you're going to set marginal revenue equal to marginal cost. There's your Q star up here, right? And you have profits, don't you? You have your cost per unit and price per unit, right? So we're starting at P0. We have positive economic profits. Yoga berries are making multi-millions. What's going to happen? More people are going to enter the industry. So we're starting out at P0. Don't forget positive profit. More people are going to enter the industry. So supply curve is going to shift to the right. As supply curve shifts to the right, prices fall to the long run equilibrium. What is the long run equilibrium? zero economic profit, and price is equal to the minimum of the average total cost curve. If I were to highlight something, it would have to be that at this point. I would have to highlight that. Given the long run, Chapter 9, firms are going to earn zero economic profit. Price is going to be equal to the minimum of the average total cost curve. What happens if there's economic losses? If there's economic losses, let's just say kind of we start down here. I'm going to move this baby. Let's just say we start down here, below average total cost, right? Say we start here down below average total cost. Well, firms are going to leave the industry, right? So supply is going to shift up to your left. So if we're currently making negative economic profits down here, we're making zero economic profits down here and negative economic profits. Some firms are going to leave. As some firms leave, the supply curve shifts left till we end up with zero economic profits and price is equal to the minimum of the average total cost curve. So whether you're earning positive profits, new firms enter, prices go down. If you're earning negative economic profits, if your price is below your average total cost, this can't exist in the long run. It's fine in the short run for a short time period, but in the long run, it doesn't exist. You can't have losses in the long run. You can't continually lose fixed costs even in the long run. So if you're having losses, then some firms are going to leave and supply shifts left in the whole market and prices rise to this point. So whether you're having positive profits or negative profits, it doesn't matter. You're going to end up there too. If long run equilibrium is present in a competitive market, so now it's telling you it's both the long run and it's a competitive market, you're going to be making zero economic profit. Long run competitive equilibrium. 1,000 identical firms in a price taker industry. In the short run, total revenues of each firm exceed total costs. Total revenues, so they're making positive profits, right? What's going to happen in the long run? C. Additional firms will enter the market. You're making positive profit. So you're going to have additional firms entering the market. Price will be driven down to where each firm will be making just enough to stay in business. Zero economic profit. So what if we change demand? Well, if we change demand, it doesn't really matter. If you change demand and demand goes up and you make a profit, well, then in the long run, new firms are going to enter and you're going to still be at the minimum of your average total cost curve. So let's see how this works. Let's just say we're starting at D1S1. We're starting at P1. Demand increases. Demand increases and price rise. We're on S1. Demand increases and prices rise. Prices rise, right? Positive profits. What happens with positive profits? With positive profits, new firms enter, right? New firms enter, supply shifts right until we end up with the short run or the long run perfectly competitive conditions. Price is equal to the minimum of the average total cost curve and zero economic profits. So even if we have an uptick in demand in the short run, eventually you're going to end up at the same place in the long run. What if we have, so in adjusting to expansion in demand, basically, supply shifts right, and what you end up with is basically a long run supply that is horizontal. So they're always going to end up, whether demand is high or demand is low, they're always going to end up at this price, which is at the minimum of the average total cost curve. Does everybody see how this is a horizontal long run supply? Here's some short run supplies that are going to shift to the right, shift to the left. Short run supplies are going to shift to the right, shift to the left, but in the long run, it's going to look like a really horizontal supply because demand might go up, but in the long run, you're going to end up at the same minimum of the average total cost curve. So the supply in the long run can be seen as kind of horizontal. So if we have a decrease in demand, well, let's just say we're starting at P1 and we have a decrease in demand for some reason. They don't want this output. People are losing money. So we have D1, supply shifts left, D1 and S1. Demand shifts left, decrease in demand, S1, D1, demand shifts left. When demand shifts left, basically people are going to be losing money, price drops. Tons of losing money all across the industry. What's going to happen? Well, people are going to leave the industry. So you have supply shift left until we end up at P1, minimum of the average total cost curve, zero profit. Again, what we're seeing is this long run supply that's basically horizontal. It may be that demand goes up, maybe that demand goes down, but we pretty much always end up at the minimum of the average total cost curve, zero economic profit. 1,000 identical firms in a price taker industry. In the short run, the total revenues of each firm are less than total costs. What will happen in the long run? D, firms are going to exit the market. Product price will rise. Firms are going to exit the market, product price will rise. All right, so with a long run supply curve, so far we've looked at pretty much a constant cost industry. Costs don't change. Demand increases, demand decreases. Costs in this industry really don't change, whether demand is high or demand is low. Your average total cost remains the same. As a result, we have what's called a constant cost industry, a horizontal long run supply curve. What may happen though, let's see if we can look at this. What may happen is that as demand increases, your costs go up. As demand increases, your costs go up. All right, so think of this. We had the housing bubble, remember that? Where everybody was doing some sort of refurbishing house, building an apartment complex. Demand for housing went up like crazy. Well, when demand for housing went up like crazy, it was impossible to get anybody to fix your house. Everybody was busy. Now, they would be willing to do it if you pay them enough, right? Costs go up. You got to draw resources in from other areas. Maybe in Florida was a huge housing boom. Well, you got to draw resources from Louisiana or Georgia to get all the carpenters down here and developers and construction people. So costs go up. When demand for housing went up, costs rose. You had to raise prices in order to draw those resources. So when demand goes up, this cost curve shifts up. And it shifts up pretty permanently when demand goes up. So as a result, zero economic profits occurs at a higher level in an increasing cost industry. In an increasing cost industry where costs rise as demand rises, you're going to get an upward sloping supply curve. Hope that makes more sense. As opposed to here, which is a constant cost industry. There's also another graph, but I thought this was a better graph than I used to have. All right, you could have a decreasing cost in industry. I've never really seen that actually occur, but it might. It might be that as demand increases, costs in the industry become less and less and less. In which case, then you could have a downward sloping supply curve. Most of the time, you don't. Most of the time, basically what we have is we have a slightly, either a horizontal or a slightly upward sloping long run supply curve. And what we see is that over time the elasticity may change, that it'll become more elastic in the longer run. It's cheaper to supply goods and services over a longer term compared to if you need it next week. If you need it next week, which is the short run, right? This is a short run. If you need it next week, you're going to have to pay more for it. Now, if you don't need it next week, you can wait a while. You'd raise the price very little in the long run if you can wait. But if you need it tomorrow, the price is going to get higher. Makes sense? It's going to be more costly in the short run to bring goods to market than if you give it a long time to produce and more time to adjust and more suppliers to enter the market. Prices will be lower. So you tend to get a more elastic or a flatter supply curve in the long run. If a product is manufactured under the conditions of constant cost, an increase in the demand for the product will increase equilibrium quantity, but price won't change. It's a constant cost, so prices don't change in the long run. You have that horizontal supply curve. If resource prices rise and the per unit cost of producing a product increases as the firms in the industry expand output in response to an increase in demand, the long run market supply curve for the product will be slope upward to the right. So this is the definition of an increasing cost industry. That is that resource prices go up as you expand production. As resource prices go up as you expand production, that's an increasing cost industry, and you're going to have a supply curve in the long run that slopes upward to the right. So profits and losses, basically, economists think that creative destruction is great. That is, you get profits. That's great because it's satisfying consumers' wants for some new product like fat-free yogurt, right? Heaven forbid that we go without fat-free yogurt, but it's definitely creating GDP growth. It's creating well-being. We have utility from that. And so that's a good thing. Creating economic profit means that you are raising the value of those resources. You've taken yogurt, you've taken a building, you've taken labor, you've combined them. And the amount that you paid for those resources is the amount that they were worth in alternative uses, right? You attract these resources, and the price that you pay is the amount that they could get elsewhere. Well, what you've done is you've raised the value of those resources. If you have profits, then that means you've combined these resources really, really well and raised their value. So it's a reward for producing a product, for raising the value of those resources. On the other hand, let's just say you're a terrible pizza guy. You produce the worst pizza ever, and you go out of business. Well, you couldn't even cover the value of those resources. You devalued those resources in the production of pizza. After you produce pizza, those resources were worth less than before you started. So losses to an economist are a penalty for the production of a good that consumers value less highly than before you started. So if you're making losses, economists say it's good that you go out of business. Go do something that you're good at, basically. So profits and losses are basically rewards or penalties for how entrepreneurs utilize resources. Competition promotes prosperity, competition in the market process. So competition is kind of the key to the market process. Unfortunately, we don't often have pure competition, but we hold this up as the beacon of the be all and end all, the most wonderful thing that's ever happened to humanity is competition. And it is because you are producing at the minimum of your average total cost. These guys, if you are in a competitive industry, this is a great way to produce resources. It's at super low cost. And so that's what we like about perfect competition. That's what we like about chapter 9. Chapter 10 and 11, things start to go wrong. We don't have perfect competition. So we'll start to look at firms with more market power, how they're going to behave differently than in perfect competition. Anyway, great speaking with you. Please email if you have any questions.